Hello everybody, today I have another question for you, and this time the question read pretty much the same. A rigid tank with a volume of, it was 3 meter cube before, now I did 300 feet cube, so I'm moving to the English units, okay, British gravitational. And I gave you how much of mass of water I have, 2 pound mass of water, and I gave you the temperature this time, just for us to practice, 320 Fahrenheit, fairly high Fahrenheit, you can see temperature, okay. The question is asking me about the pressure. The question is asking me about the quality of the mixture, if obviously applicable, okay. It may not turn out to be in this steam dome, okay. And it's asking me the total internal energy. As always, please do not watch along with me. Just try to solve it on your own, okay. So the first goal for me is to kind of like draw a PV. Why am I drawing PV? Because temperature is constant, right? I have a PV diagram. It's like a steam dome, something like that. It's not that important. And the way we draw it is going to be like this, fairly steep, going like that, and then I will go like this. Okay. So this is my temperature is 320 Fahrenheit. Okay. So then what I'm going to do, as we discussed before, I will try to find my specific volume of these 2 points that I identified, okay? Because in my system, I gave you the volume, which is 300 feet cube, and I gave you the mass as 2 pound mass. So then I can find exactly the specific volume for my case, which will be, you can see, 300 feet cube divided by 2 pound mass, so 150 feet cube per pound mass. Now the question is, where is 150 feet cube per pound mass? Is it here? Is it here? Is it here? Is it here? So my analysis will be quite different depending on it. So my goal is to find these two values right over here. Okay. In order to do that, obviously I'm going to look at the saturated water tables, right? And if I look at the A4, but this time it's English unit, so I'm going to look at A4E, and I'm going to pick the temperature, you can guess, as 320, and I'm going to note down what these values are, okay? So I'm actually literally looking at it right now. So this one is 0.01765, okay? Fairly small because it's pretty dense, the liquid, right? And this one is 4.91 something, doesn't matter the rest, okay? Now you can see where I'm at. So my 150 is actually significantly, this is like, let's say 5. So this is significantly, to the right. So you can guess that actually, just to give you some insight, I'm also looking at table A4E this time around. Actually, if I were to ask you pressure over here, this is going to be 89.667 psia, okay? So what this means is this is the absolute value. You can see here there's an A there, so that's nice. But what I am saying is, as my 150 is going to be fairly down here, okay? The point is the pressures that I should get should be significantly lower than that, okay? The way that we drove this line, just that like information for me to get going, okay? Then what I'm going to next is I have to go to the superheated, right? This is in the superheated region, like clearly, no question about that one, right? So then what I need to do is I need to go to the table A6E, okay? E because it is English units, but A6 if you're using SI, the numbers were given as SI, okay? So this A6 is, I showed you in the previous segment, it's kind of like a little differently arranged. So there's different pressure values, okay? But one thing that I know for sure is 320, okay? So I need to find the superheated water, I need to find 320, and I need to find something that is close to 150, okay? So when I look at it, I'm going to write in here. So let's say that P is equal to 1.0 psia, okay? At that particular pressure, here is what my specific volume is supposed to be, 464.20 feet cube per pound mass, okay? So I'm looking at this value. Whoa, okay, wait a second. This is significantly lower than that. Then I look at the 5 psia. I don't have any other data for 2, 3, 4. This is what, it's a discrete. So P is equal to 5 psia. And I'm looking there and I note that this is 92.650 feet cube per pound mass. Okay. So now the question is this: you know that my number is right in between. So then I have to do some type of interpolation. And interpolation will come in handy in this A6 a lot, okay? It's kind of rare that you just are lucky that it corresponds to here, okay? So if I look here, then I need to find this value over here, this P, okay? So now I have to look at the interpolation. But one thing I want to highlight is this is like an X, the way I gave you, right? This is the X is known, the Y is missing. So the equation that I'm going to write should be this way. So now the interpolation is going to look a little different. 5 minus 1 divided by, okay, 5 is 92.65 minus 464.20 will be equal to, well, X, that's, I don't know, this, minus 1 divided by 150 minus 464.20. So if I go ahead and find the X from here, in this particular case, you will see that this will be the answer to my question, 4.38 psia, okay? So if I go up over here, this will be 4.38 psia, okay? So that is the answer. What about the question B? What is the quality? Well, there's no quality. Quality is only defined within this here. So basically the answer is does not exist, okay? So this doesn't exist. And what about the part C? Now I know my pressure, right? Now I know where I'm at. So let me move them down a bit so I can write another line. So I'll now go ahead and write this U values for 1 psia and 5 psia, okay? And those numbers will be 1118.9 BTU per pound mass, and this U will be 1118, no, I'm not making a mistake, 0.4 BTU per pound mass. So you can see the internal energy doesn't change much between those two fairly low, relatively speaking, pressures that we have, okay? So then we have to do another interpolation here. Now I'm not going to show you that, it is the same thing, you know, so wherever you write this value, you just replace by, you know, this minus that. Actually, you may not even need to do it because the final answer will not change much, as you can imagine. But, you know, this X value will turn out to be 1118, no surprise there, 48 BTU per pound mass, right? That's the unit, okay? And so I know my U then, okay? But the question is asking about the capital, so that it's not the specific, but rather the total. So now I'm going to multiply 2 pound mass times 1118.48 BTU per pound mass, right? You can see pound masses cancelled. And I get myself 2,236.96, right? That's the twice of 48. BTU. So 2,236 BTU is the internal energy of that particular system. So this is my final answer, okay? Okay, thank you for watching this segment.